So here you see our next engineering mechanics problem, force vectors acting on a hook. And as always, let's read the problem statement first. So here we have to use vector decomposition method to calculate the resultant force on the I hook. And then you also need to find the angle relative to the positive x-axis. And I want to point one important thing out here. This is actually mentioned in one of the previous lectures that hopefully you read up on, because it's a very basic concept that we use all the time in engineering mechanics. And it's something you should be familiar with before you come to the class. But it's written out for you in detail. And I will explain it now here, just so that we're all on the same page. So this is called the 3, 4, 5 triangle. And what students tend to do when they see this problem first is they try to convert this into an angle. They try to calculate the angle here and then figure out the components for this force. But I will avoid this now, and you will see that A is much faster and it saves a lot of time on my exam. And B, it's much more precise because I'm dealing with fractions. So let's go through the problem in total and let's see what we have. So maybe it's best for me to write down all my forces first. So for example, F1 is equal to 300 I hat plus 0 J hat. And that is in Newton. My F2 is really equal to 400, and I'm going to use a different way to write this now, 400 cosine 30 I hat plus sine 30 J hat. So for those of you who are puzzled by this, right, so the x component actually is always the x value is always defined by the cosine function, and the sine function always defines the y value if you always measure from the positive x to the positive y. That is also explained in the written lecture where I explained the 3, 4, 5 triangle. So please read up on this if this is confusing you. However, I need to include my unit here. So these are newtons. And now I have my last force, F3. And now this might go fast for you, but again, you can read up on this. This is available in the lecture script in the very beginning in one of the 0 lectures. So 250 Newton has to be really divided by 5 and multiplied by 4 to be the I component. And that is positive. Now I need to be careful because the J component is negative, and that is divided by 5 and multiplied by 3 J hat. And now I have all my components of all my forces written down here. So the last thing I need to do now is vector addition, and I just need to combine all these numbers. So let's write that down. So my F resultant is really equal to 300 plus 400 cosine 30 plus 254 over 5, and all of this is I hat. And then I need the J components, which are 0 plus 400 times sine 30. And be careful now, minus 250 times 3 over 5. And that is all multiplied by J hat. And I cannot forget that this has a unit. Otherwise I lose valuable points. And in this case, we're dealing with newtons. So now my F resultant can be calculated. And that turns out to be 446.4 I hat plus 350 J hat. And again, don't forget the newtons. And this is one part of my answer, so I better double underline it. So there we go. And now I need to find the magnitude of that F resultant. So F resultant magnitude is equal to 446.4 squared plus 350 squared, and the whole thing square rooted. And that turns out to be 567.3 Newton. Of course, if you punch that into a calculator, you will actually end up with like more digits, but keep in mind our 4 significant figures rule. That's also listed in one of the previous lectures. So do not list more than 4 significant figures. You would lose points. So that's what I'm doing here. And last but not least, I now need to find out if my resultant force has an angle to the x-axis. And to do that, it's always good to look at your sketch, because again, you need to know if it's in the first or second quadrant. And in this case, you see that all the numbers are positive. So that means that you are in this quadrant, so your tangent function works. So I can do that. But before I do that, let me just draw that resultant force so that you clearly know what's going on here and what numbers have we calculated. So this was equal to 567.3, and then we had a x component which is given here and a y component which is given here. And so x would be equal to, what did we calculate? 446.4, whereas the y component would be equal to 350. And so just to be clear, what I'm trying to calculate now is this angle, let's call it theta. So theta then can be calculated by rise over run in this case. So theta is equal to tangent inverse of 350 divided by 446.4, and that turns out to be 38.1 degrees. And last but not least, double underline it. And here we go. And this completes this particular problem. And I believe everyone should be able to solve problems like this now. Of course, to emphasize this and to practice this, you have homework assignments that deal exactly with these concepts. But this now finishes this problem. And we, of course, gave our 3 standard answers for vector problems. And therefore, we're done. Let's move on. So here we have our last problem in the lecture, and this one states that we are supposed to find the resultant vector, specifically its x and y components, but notice that no specific method is required here. Of course, in this case, I would argue that if it asks you for x and y components, that the vector decomposition is simpler. However, you could use any method you really wanted to. And this problem is very similar to the previous one, except that you're now dealing with angles outside of the 90-degree turn here. So I'm not going to solve this problem actually for you. I'm only going to give you some hints and the final results so that you can solve this and check your work at home. The first hint I want to give you is here the 5, 12, 13 triangle. This is similar to the 4, 5 triangle in the fact that here you will definitely end up with a 90-degree angle if you have a side length that is 5, a side length that is 12, and a side length that is 13. So you can relate these to each other. And just because that is often new, I can tell you that F2x, for example, would be equal to 260 Newton divided by 13 multiplied by 12. Right? So that is because the 260 is parallel to 13, so I put that here, and the 12 is what I'm trying to find, so I put that here. And the same would be true for y. However, be careful that you understand that we're moving in a negative direction here. In fact, that gives me a chance to talk about something else that sometimes I see go wrong for students. And that is the direction of the components. So the way I like to look at this is, if I want to go in this direction from the top to the bottom, I can either walk along the diagonal or I can walk down first and then to the right. But what sometimes happens, and I will erase this in a second, is that students actually show me a triangle like this. And that, of course, does not work. So please do not do that. Please be careful. Let me erase that. So yeah, stay away from that, please. That is something that can go wrong. Then another thing that I need to point out here that is very important as you move on through the lecture is that this 30 degrees is often used for students to find the y component. So the way they calculate this is by saying that f1x is actually equal to 200 times sine 30, which is absolutely correct, but it's a bad habit to form, right? So this is correct, but I would still stay away from it. In fact, I would say that f1x is equal to 200 times cosine 90 plus 30, which of course numerically in this case is the same value. However, this method is much more foolproof and bulletproof when you deal with like more complex systems later on. So what I'm trying to really tell you here, and what I want you to form as a habit, is to always move an angle from the positive x to the positive y. And so therefore it's counterclockwise, right? So always measure your angles counterclockwise from the positive x to the positive y. That is very important. When you solve problems like this, you might get away with what's given here on the top, but so this will work, of course, and if you do it rigorously and always correct, it's fine. But I see this leading to problems when the problems become more complex. So if you form a habit and use the unit circle, in which it's always measured from the positive x to the positive y, you are much better off memorizing that cosine is always x, the x component, and sine always leads to the y component. And when you do that, by the way, you never have to worry about positives or negatives. In fact, if you type this into your calculator, you will find that you will find the negative component here. So it will automatically be a negative value. Whereas this one, you have to do that yourself. And again, if that's a complex problem, that can become tricky. So I, in my life, decided that I always use the angle measured from the positive x-axis. And of course, then the same is true for the y direction, right? So I would say that f1y is really equal to 200 times sine of 90 plus 30. And that will help you. And then again, I say it one last time, whatever you do down here, it is worth it to really internalize this here for the rest of your career as an engineer, because this will make your life much easier than using angles and try to use strange numbers here. You just make your life more difficult. That doesn't need to be the case. So please stay away from that. And with that said, I think you have all the tools you need now. So let me give you the final results so that you can actually check your answer. So I can tell you that F resultant here in this case has components of 140 I hat and 73.2 J hat. And F resultant magnitude is really equal then to, I mean, that everybody can calculate easily, I guess, from the number that I've provided, 158 Newton. And then we have theta, which is equal to 27.6 degrees. And of course, all of these are results, so I double underline them for you. I don't want to lose points. I hear the teacher is very strict about that in this class, so I better double underline this. And of course, I'm going to give my answer arrow here. All right, and I believe this gives you all the information you need to solve this problem, and also all the information you need to really complete any assignment in this lecture and with the concept of vector decomposition or using trigonometric laws.